Good morning, everyone. Thanks for joining us today. Today we're going to review B&G Systemwize, and we're also going to throw in some tips in there for you. I'm Sunday Perez, Corporate Marketing Manager for CHC and Flowtherm Systems, and our instructor today is Paul Campbell. If you guys have joined us on our other webinars, you know how awesome he is, and he's going to do a great job for you today. Before we get started here, if you have any questions, please use the chat function. You'll find that at the bottom of your Ring Central meeting screen. As we kind of go through sections, we will pause and review any questions at that time. Paul will kind of cue us to that. And then at the end, we'll review any questions that remain open and hopefully answer all of them before we close out the session for today. A few of you have asked about recordings, and yes, I am sending out the recordings. I'm a little bit behind, and I truly apologize. I did send out the first recording, though, of our first session we had a few weeks ago. So if you did attend that or register for it and did not receive the recording, please email me at S as in Sam, Perez, P-E-R-E-Z, at chchydro.com. I'm going to put that in the chat to the whole entire group, that email address. Feel free to reach out to me if you have any questions. All right, with that, I'm going to hand the reins over to Paul. Paul, are you ready?
I'm ready, yeah. Good morning. All right, listen, thanks again for joining us this morning. We certainly appreciate your time. We know it's busy and hectic out there, so appreciate you taking a few minutes with us. This shouldn't last an hour. I'm thinking 30 to 40 minutes. We'll see how it goes, but I shouldn't have to speed talk through this like I did last week. We just kind of wanted to review some software basics. This is something that we, on the rep side, we spend our life in, or a vast majority of our day doing. And we kind of wanted to, if you're dabbling with pump selections or looking for software, we just kind of wanted to review some basics with you. We're certainly glad to help on any aspect of that, but we wanted to kind of point out some tips and tricks, if you will, as well as how to navigate and set things up. And that's kind of that was the goal this morning. I'm going to bounce around between a few screens. My presentation this morning is just trying to highlight a few things, and then we'll get into an actual couple sizing examples where we get into software, and we'll spend some more time there. So I'll be bouncing around between screens, try not to make you sick in the process. The first thing to touch on is if you're looking for WebExes that B&G's already done, I know we're doing a series on Systemwize, but B&G has also covered Systemwize on a couple sessions. If you go to their website, bellandgossett.com, under training and education, you come down here to the remote learning hub. If you click on that, you'll end up with an area like this, and as you scroll down, you'll start picking up some sessions that have already been given and the ability to watch them now. So you'll notice there's actually 2 on Systemwize. There's another one on modern pump selections. All these take roughly an hour, but they're already pre-recorded. They're already on their site. It's an easy reference. So just throwing that out as well. I'm gonna cover some things, but I'm not going to get in too deep. So if you're looking for more information, there's certainly a way to get that as well. Okay. As usual, I've got a couple polls, not as many this time as previous, but I'm going to go ahead and launch poll number 1 here, which is regarding your possible experience with Systemwize. I don't know what that is, but we'll throw it out to the group. If you haven't used Systemwize before, it's just a matter of going to bellandgossett.com. Under Selection Tools, you'll scroll down to this thing called ESP Systemwize. And that's actually the selection software for pumps, hydronic specialties, that'll get you to heat exchangers and pump trim, expansion tank sizing, things we're going to review this morning, okay? Once you click on Systemwize, you'll end up with kind of a home screen like this. And it's important to know that we're going to be navigating over here on the left-hand side. So with this, I'm going to go ahead and end the poll. we'll share it. Let's see how many people are familiar with Systemwize. Yeah, that's interesting to me. So not a lot of people. Most are saying, "Hey, I've never used it. What's it look like?" We're happy to do a lot more in-depth help for you here, but we'll just cover some basics this morning. I use it all the time and like improvements that are being added. That's one thing I've found is behind the scenes they're constantly tweaking software, this cloud-based version, and you get some nice little features in there that weren't there the week before. So if you're in there quite often, you'll notice some improvements that are being made. I've had a lot of internal individuals within CHC get a little frustrated. They may not understand what software is doing as far as selection process, so they get frustrated and they'll bounce to other software that we might have available, or some old software that's no longer supported. But the inconsistent results, I'll try to explain that when we get into pump selections. That can certainly be a source of frustration. Thank you for participating. Personally, the more I use it, the more I like it. So I'm kind of on the last category, but I may be a little jaded too. So let me stop that. Let me continue on here. So it's important to note when you're in Systemwize that the way you navigate back and forth between multiple selections or criteria would be over here on the left-hand side as far as navigating menus, bouncing into a schedule versus pump selection versus some trim. Okay, all that's done on the left side. Now, one thing that's really helped me personally is when you go into your account, well, let me back up. The first thing I should note is when you sign into Systemwize or when you first access it, you should get some reference that you're signed in. If you don't, you can click on this. It'll say ask for password or login information. Reps aren't in charge of that. B&G isn't in charge of that. You create your own username, your own password. So once you go to the site, it's just a matter of entering some of your information, what you want to use for a username and password. You'll get it kind of auto logs you in, and you're off and rolling. But every time you log in, it should reference you. If not, you may have to remind it of your username and password. Okay. Under this left menu, under your account, one thing that's really helped me is I don't care about my information, but I do care about settings. And when you go to settings screen, you can control what you're looking at every time you make a pump selection. So you can toggle these on or off depending on what's important to you. You know, for me personally, I don't really care about pump efficiency indexes as it relates to selecting a pump, so I tend to turn those off. But if those were critical in your selection, you can reactivate them. What I found is the more information you select, the larger your screen becomes, and you end up having to scroll left or right to review your pumps. It's way easier for me to have it on a single screen. And by eliminating some of these selection points or columns, that speeds that process. So just a helpful hint. In software too, I'll show you that they've added a kind of a shortcut for this. We'll touch on that when we get to our example. If you're creating schedules, if you're saving pumps to a schedule or equipment to a schedule, it's very easy to do. You can go, they're constantly saved on the cloud. You can go in and modify them or change pump tags or go in and change conditions. Just by editing equipment, you can rename a schedule. You can modify which schedule you're looking at or which job you're working on within schedules. So to me, schedules are kind of a powerful tool for keeping all your equipment selections in one location. You can also get I'll show you later, but you can get a spreadsheet version of this. You can get documentation for all information that's included on that schedule, whether it's CAD, Revit, and or submittal information for that. So pretty powerful tool as far as creating schedules. You can only create a schedule if you're logged in. So just a heads up on that. If you're looking for replacement parts, I know that can be a source of frustration, but on Systemwize, there's an option for that. You can do it based on a general bill of materials. You can search based on part number or by product information. So there's a number of tools there to help you with replacement parts. Obviously, we're around for that too, but if you want an online resource, that's certainly available. If you're getting frustrated and things aren't working for you the way you hoped, if your screens are limited or you're having problems, there's this nice little chat window that's almost on every screen. If you click on that, you get a little pop-up that says, hey, let us know how we can help. Tech services are great. You could send them kind of an instant message. You could send them a screenshot. They usually confirm within 30 seconds to a minute that they've got it, they're working on it, and sometimes they'll help you right on spot. Obviously, they have working hours, so if you're working at 2 in the morning, they're probably not going to help you right away, but they're very good at getting back to you and following up. So again, if there's source of frustration and you can't get a hold of us at CHC, you want to go right to B&G, that's fine. Send them an instant message. They can address your problem. The other thing to note, you'll see a lot of these little blue eyes on the windows. Every one of these eyes is an information button. If you click on that, depending on what screen you're at or what eye you're selecting, you may get some really detailed information back. If you're curious what pump PLEV means, part load efficiency values, this is how they calculate it. And if you're curious about censored versus sensorless, there's definitions for that as well. If you just want to know what control head means and what effect that has on your pump selection, when you get to control head, you can just click on the eye and you get a kind of an information button that shows up with a little more detail for you. So those can be really helpful, and we'll reference those when we get into our selections. Another thing that's a great little tool here are expansion tanks. For me, I really like B&G's tank selection software. It's super easy to use. And I just kind of wanted to touch on some highlights. You can change any one of these fields as far as entering temperature, max temperatures, fill pressure, max tank pressure, which is your relief setting, and then system volume. There's calculators here too, based on your line size and total lengths, to figure out roughly what your system volume would be. And then if you're using something other than water, you can certainly change it for glycol mixes and work there accordingly. As you enter this information, you're going to come up with your acceptance, which is total water expansion, as well as a tank volume. When you go to the next screen, you'll end up with some tank selections. I want to caution you here a little bit. So if you're using this, one thing that can get you in trouble is looking at this quantity. The first three are individual tanks, meaning one tank would work for that system. When you get down here a little lower, you'll notice there's a 2 next to the tanks that are in question, and sometimes there's 3 next to it. Well, that's not a ranking based on price. That's how many tanks you physically need to accommodate 2,000 gallons of expansion. So you're always better to deal with a single tank than you are with multiples. So again, just a heads up, I would only be looking at quantity 1, not quantities 2 or 3. That can get you into trouble. Let me launch the next poll. Forgive me, I got to put up reminders, otherwise I space it. So my next little poll is regarding heat transfer, and that's my next little section here on Systemwize. There's a tab or a menu for heat exchanger selection. This is the same software that we use internally as far as a rep goes. It does require a separate password, so this can create some confusion. But if you select on this selection program, it's going to kind of prompt you for some user information so that you can how do I say it? So that Xylem or B&G can generate a password for you. Once you have a password, you can get into ESP Thermal. It gives you the option to select braze plate, gasketed plate and frames, shell and tubes, tank heaters, whether you're using water-to-water, refrigerant, or steam. You've got options for all of those. Okay. In general, it takes you to kind of a, I don't want to say it, factory standard conditions, but you can modify any one of these. There's a lot that goes into heat transfer as far as understanding the cost impacts of approach temperatures as well as pressure drops, fouling factors, over excess surface area. There's a lot that goes into heat transfer, but if you're pretty competent on that, you're more than happy to use this. Bear with me a second. Ultimately, on plate and frames, you end up with selections. This is the same information we look at on the rep side. It also includes lead time, which can be an important selection criteria. And these are accurate. They constantly get updated based on factory inventory. So that's important. The thing that can get misleading for you on heat exchangers is this price factor. Obviously, the first selection is the cheapest. The last selection is the most expensive. But I can't tell you if this is a $1,000 heat exchanger, a $10,000 heat exchanger, or a $100,000 heat exchanger. So for me, having access to list prices, which is what we have access to on the rep side, helps narrow down some selections and maybe provide some alternate selections for you. So if you're trying to be price competitive or look at budgeting, we probably want to get the rep involved. Okay, we can certainly assist on that aspect. Let's see. Let me go ahead and end this poll, and I'll share it. Thank you for participating, by the way. Would you have any interest in heat transfer session? I'd enjoy learning more about heat transfer. Thank you. We would probably spend a solid hour on heat transfer, bouncing between shell and tube, plate and frame, braze plate, and cover this in some more detail. Maybe for some things to look for, some red flags on projects where you can get yourself into some trouble, and examples of good selections. So yeah, thank you. We'll add that to the list Sunday if we could do that. Okay.
Got it.
Let's look at our let's bounce into software for a second. Again, we're 20 minutes in, so we're doing pretty good so far. What I did was pull a kind of a sample schematic that we've looked at before. Maybe 2 system pumps rolling out through the system, bringing flow through back through our boilers as far as variable primary goes, or primary only. So the system flow is handling the flow through the system as well as through the boilers. I picked some big boilers in this case, 3-4 million BTU boilers. So each one of these is 4 million BTUs. Give me the 12,000 BTUs in my boiler plant. And if I assume a 20-degree delta T in the system, I know typically it's 40, but let's just assume it's 20 because that gets me to a nice round number of about 1,200 gallons a minute. And I'm going to assume 80 feet of head resistance out in my system through my piping. Okay. If I'm trying to select a pump, I need to know how we're staging these pumps. And for this first example, we're just going to assume lead lag, or only one pump's running at a time. Our second example, we're going to look at these pumps in parallel. So let's just focus on a single pump just to keep life simple. And 1,200 at 80 is kind of our condition. Now let me switch screens. Let's see how this works. And once we make some pump selections, I'll come back into PowerPoint and we'll kind of evaluate our selections a little bit. And then we'll move to our next example, okay? Well, let's see if I can get this to work. Is that showing for everybody? Are we seeing ESP Systemwize on your screen? Sunday, does that work?
No, we're still seeing the pump selection.
Okay,
Yeah.
let me change my share then. Let's just do this. How about now?
Yep.
Okay, thank you. So let's see, I lost my laser pointer, but that's not critical. There we go. So this is, we're in Systemwize right now. I'm logged in, which is fine. One of the things that that's important to do is this clear inputs. So if you're getting some garbage from a last selection, or you're doing repeat pump selections, one thing you may want to do is just clear inputs to make sure that any criteria that you had previous is erased and you're kind of starting over. Okay. We've got options on our pump selection, and we're just focusing on pumps right now. Most of the pumps out there are going to be running as variable speed. If you're old school and you're looking at a constant speed selection, you can do that. If you select variable speed, you're going to get both a constant and a variable speed curve. So my default's always variable speed. If you're going to go sensorless, you have the option to do that, or you could look at both. Typically, I'm looking at sensored, which means control contractors providing a 0 to 10 back to a drive and controlling the drive speed. Right now, I'm under Express Select, meaning I'm going to select which model number I'd like to focus on. If you don't know model numbers, you can eliminate that, and now you're looking at pictures for an in-suction versus an inline versus a split case. Okay, so if pictures are easier for you, just undo the Express Select. If you don't know what a 1510 is, you can also pick on the select on the I button, and it'll pull up kind of a picture for you. Product of the year, you know, we're all proud of that. And if you really have no idea where to start, this product family can help narrow things in a little bit. So our flow rate was 1,200 gallons a minute, somewhere between 1,000 and 1,500. That puts us in with a possible inline, puts us in with an inline split coupled, or a base mount. So all those are kind of viable options. As far as anything that's in red is considered an optimal selection point. To make life easy, I'm just going to pick a standard in-suction base-mounted pump, just so we have one option to look at. You could pick multiple selections here. You can pick them all if you like. That's there's no problem there. So let's scroll on down and let's enter our flow rate. We're doing 1,200 gallons a minute at 80 feet ahead. Software is going to calculate our control head, which is kind of our minimum pressure required in the system. They estimate 30% of our design. So as soon as I hit enter here, 30% of 80 is 24 as far as our control head or minimum pressure in the system. That's about 10 pounds. If you're going to operate less than that, you can certainly override it. Right now we've got a single pump. If we're going to go lead lag, we can add a standby pump. So there's two in our system, but we're only looking at one as far as operation point. If we come down here to motors, we can kind of fine tune our motors if you like. Kind of our default is non-overloading, but if you just want to look at selecting horsepower based on duty point, you could do it here. You could also pick what motor frame you've got. Most motors are NEMA Premium. For me, I tend to leave this alone. It doesn't have any impact on my pump selection. Overspeeding, this really only applies if you've got a full-size impeller. Software will let you go 10% overspeed, assuming you've got enough horsepower. I usually don't include this as my initial evaluation, so I tend to turn that off. And then you could change your enclosure. But again, that open drip or TFC. To me, these don't have a big impact on pump selection. If I just want to focus on 1750 or 1800 RPM selections, I can do that here. But at this point, I just kind of want to see what's available. The other thing is, if you're using something other than water, you can certainly make corrections for glycol and temperatures under fluid type. Okay, so that's basics of pump selection. Let's go ahead and get results. I know this is just fascinating watching somebody run through software, but what you end up with on results is kind of curve shots as far as where, where individual pumps fall on their pump curve. As we scroll on down, you'll see they're a little different. And then kind of summaries off here on the right-hand side. Again, the more columns that you select, you'll notice that I have to, if I can do this, I have to scroll kind of left or right to pick up these columns. Okay, so that, for me, that's a point of frustration. I want it all on a single screen. Now, changes to software, they're allowing you to modify that right here under hide and show columns. So if I click on this, I get that same selection point or curve column selections, and I can turn off NPSH if I don't care about it. I can turn off my price index. I can turn off a number of things, trying to simplify my selection. Okay. Now, if you're not familiar with kind of editing pump selections, what I did is I took this and I dumped it into PowerPoint. So my hope is to go back and kind of look at these same selections in a little more detail. Let's see if this is effective or not. Let's see. Is that working for everybody? Sunday, are you seeing a PowerPoint screen at this point?
No, we're still on.
It's a fail. It's a fail.
That is a PowerPoint screen.
Oh, is it? Oh, okay. Sorry, it is.
Yeah, see the logo at the bottom? That's
Yeah.
good, Paul.
Thank you. Yeah, thanks, Hans. So yeah, is that working for everybody now?
Yep.
Okay, we're back. All right, great. So all I did was take those same selections we were looking at earlier on Systemwize and dump it into PowerPoint. And this allows me to kind of highlight or focus on a few things, if you will. Right now it's ranked on part load efficiency value efficiencies. Okay, so you'll notice that the top one is our highest at roughly 83, 84%. Our bottom pump is down at 65%. So not great on part load efficiency values. You could rank your selections on horsepower. You could rank them on duty point. You can rank them on RPM if you like. There's a lot of things to look at. There's also a price index over here, which again can be a little misleading, but it's just trying to rank the pumps as far as how they fall on a list price value. So clearly number one is our cheapest option, and they start to get a little more expensive or change or modify as we move down the chart. So one thing I threw up here, let's see if this works, is maybe some areas that we might consider eliminating. You know, if we're concerned about a high-speed pump, 3,600 RPM, in this case the pump's running at just over 3,000 RPM to meet duty point. It's also really ugly on its pump curve as far as being far out to the right. But we may not want to look at that pump. Okay, and there's a couple of these that are at 3,600 RPM. We may want to eliminate the bottom pump just based on poor efficiency. You'll notice it's far to the left of best efficiency point. So we can, process of elimination, we could probably get rid of that. The other thing that may be an important factor is floor square footage, as far as how much room, physical room that pump would take up. Some of these are a little large. So if floor space is critical, that might take those out of the equation. The second one in order here is also fairly large as far as floor space goes. But by doing that, by kind of running through the chart, you'll notice, hey, we eliminated the last one, second to last, these two, the third one. All of a sudden, pump number one is looking pretty good. Now, typically, you're going to have 2 or 3 pumps to evaluate. But you can kind of use a common sense factor to help narrow that down. Okay, so pump number one is probably our optimal choice. And what I'm going to do here, yeah, let me bounce back to Systemwize, and we'll take a harder look at pump number one. Okay, now I hope this works. Bear with me, Sunday. I changed screens on you. Is everybody tracking? I'm back on Systemwize.
Yep.
Okay, thanks. So let's look at this. There's a couple things to highlight here. If you want to look at a curve shot in quick detail, just expand this one on the left, okay, or this little snip. It's going to give you 2 options. First one is kind of a constant speed, showing here's 1,200 gallons a minute at 80 feet. Here's our minimum Discharge pressure, which is our control head at 24 feet. Notice it's highlighting our impeller trim at 11 inch. We're also using 40 horsepower because we selected non-overloading. Okay, so that's constant speed. If we change over to variable speed, we don't have to run our pump at 1750 to hit duty point. It only needs to run at 1704, so a little bit less. But kind of gives you some curve profiles at various speed inputs. All that's good information. Kind of confirms, hey, we have kind of a decent pick. We're a little bit to the right of best efficiency point, but as we slow our pump down, we're staying in good efficiency ranges. Now, if this was an open system, NPSH might be a consideration, but at this point, we're assuming a closed-loop hydronic system. Now, what we just looked at was this curve shot here. If we want some more information on the pump, we have to move a little bit to the right and kind of select on the pump itself. We'll get a lot of good summary information as it relates to in the curve flow rates, duty points, and there's some things we can change here which are pretty slick. As we scroll on down, we're looking at a variable speed curve. We can also pull up the constant speed curve. One thing we can do to this is we can add some speeds. If we want to see how this pump performs at maybe 1500 RPM, well, we can add that to our curve. Okay, if we want to look at 1250, we can add that to our curve. Okay, so we can kind of complete this a little bit. We can download this as an individual PDF if you like, just for those curve shots. We can also we can change impeller sizes if we needed to, just by changing the diameter here. You have to be careful. You kind of have to know what you're doing. But you have options to kind of modify our pump trim as it relates to our duty points. We have to watch our horsepowers and everything else. If we like this pump, we can add it to a schedule, or we can just pull documents off this pump. I usually don't do it from this screen, but let's look. If we wanted documents on this, there's we can kind of get a generic submittal for it. We could get a Revit file and overall dimensional drawing and a CAD file. We can get all four of those as a zip file. There's also generic submittals. There's specs, brochures, O&Ms, replacement parts. There's all sorts of information on here, kind of in one general area, which is pretty nice. Now I can add this to my schedule here. I can also go back to my selection point, and I can do the same thing over here on the right. Usually this is where I do it simply because I'm comfortable with pump number one after looking at its curve. So if I want to add this pump to the schedule, I'll go ahead and do that. Now this was something I created yesterday. Let's just create a new schedule to keep things clean. We might call this session number 4. Okay, we're going to go ahead and just be able to create. Our tag for this might be 1200 at 80 feet. We can add TDH if we wanted to. We can add a drive if we like. We can come down here and add some pump trim, suction diffuser, triple duty valve. So if we go ahead and add a suction diffuser, software's smart enough to know what size pump we just selected. Now it's asking us, well, what's the system line size? Is it 6-inch or is it 8-inch? Well, based on 1,200 gallons a minute, I probably have 8-inch line. So I'm going to go ahead and select that, which will add it into our schedule. Okay, quantity, we've got 2 pumps. We're going to use 2 suction diffusers. And forgive me, I might have a problem here. Yeah. Okay, so save is at the bottom, and my screen's a little enlarged. So right now I'm just gonna close this, and we'll pretend that we've added this to the schedule. I've got a cheat at the end that'll get me out of trouble. Okay, but that's basically all we've done on adding a pump to this at 1,200 gallons a minute. Let's say that we also want to pick up an air or dirt separator for the same project. If I select on that, I've got an option to add a standard centrifugal. I could also go coalescing. Software smart enough to know, hey, our pump flow is 1,200 gallons a minute. You probably want an air separator sized for the same. So if we get results, we can scroll down and look at which one would we like to use. Well, we've got an 8-inch line for 1,200 gallons a minute, but we could also use some coalescing if we like, whether it's non-removable or removable internals. So however you like to look at this, there's definitely a cost impact to go coalescing, but that's certainly an option. We can select, maybe add an air vent to it, and we'll go ahead and add to our schedule. We'll just call this Intercept 1. Okay. And that's that add button I was missing before. So we've added some things to our schedule. Now, I hope that makes sense as far as just bouncing around software. Let's go back and look at, bear with me a second. I hope that's showing up again. We're back to a PowerPoint. Let's look at a second example, okay? Or call this example number 2. Is everybody seeing this, by the way?
Yeah.
Okay, thank you. I've got a poll coming up. So in this case, same conditions, but let's assume that we're going to run these pumps in parallel, okay? Instead of lead lag, we're going to run these together depending on capacity required in the system. So let me launch a poll here. More about parallel pumping. Let's see how this goes. All right. Now let me, while the poll's running, I don't know if I can do this or not. We'll leave that up, and I'm going to jump over back to Systemwize. See if that works. Okay, yeah, that's still working. Okay, so I'm going to go back to pumps. What I'm going to do is I'm going to clear my inputs just to make sure I'm kind of starting fresh. I'm still picking a base mount pump. My flow is still 1,200 at 80 feet. In this case, I've got 2 pumps in parallel, not just a single pump. So I'm going to select based on 2 pumps. Nothing else is going to change here. I mean, my poll's kind of in the way, and we're going to get results. You notice my my pump PLEV kind of went away. My efficiencies went away. Oh, I'm sorry. I don't know how my poll's doing, but we're ranked on efficiency at this point. Now I'm going to do the same thing. I'd like to take this information back into a presentation, and we'll evaluate this. Now, and we'll also look at results of that poll. Okay. Now let me go ahead and here we go. I'm going to go ahead and end this poll. Let's share results. Hopefully everybody's seeing that. And what I asked you on parallel pumping is, what are true statements relative to parallel pumping? Parallel pumping increases the discharge pressure. That's not necessarily true. I hate to say it. Typically when we're parallel pumping, we double the flow rate. So the discharge pressure would stay the same. Discharge pressure increases if we're running pumps in series, like we do with a multi-stage or one pump serving the next. Parallel pumping, though, we tend to double the flow rate. This has no effect on pump performance. I'd be careful with that. A little caution there. System line size can have a big effect on parallel pumping performance. If the line is sized for 600 gallons a minute, not 1,200 gallons a minute, we'll have a hard time getting to 1,200 or how do I say it, or design conditions, okay? Parallel curves should cross the system curve. That one's also really important. So we're going to review that here in just a minute. Thank you for participating in the poll. Certainly not trying to pick on anybody, just throwing out some fundamentals on parallel pumping. So here's our same summary that we looked at on Systemwize. If I can go to our next screen, We can also kind of evaluate these based on maybe a price index, maybe floor space, horsepower, RPM. There's a number of things we could look at here to try to eliminate a few selections. And you'll notice that we might get, here we've got 1, 2, 3, or 4 possible, 1, 2, 3, 4 possible selections to look at, okay? So software doesn't give you any red flags for parallel pump operation, so you kind of have to be smart enough to evaluate these curves. And let me go a little further, and we'll bounce back into Systemwize to do this. What we're looking at with parallel pumping is we want to make sure that an individual pump, when it's operating, can cross the system curve. Here's 2 pumps in parallel. Basically, you've got an individual pump curve, and then both pumps running is what we're looking at with this second curve. All you do is you take a flow rate here at 600 and you double it, and you're doing the same for each point, okay? It just doubles. So the system will see 1,200 gallons a minute at 80 feet when both pumps are running. The problem is if we want to shut a single pump off, or one pump off, and just rely on one pump to run, this pump is going to try to operate where it crosses the system curve. And unfortunately, there's quite a gap here. We're running past the published pump curve, and this has potential to cause some real problems. High NPSH, unstable operation, a lot of noise. You could ruin the pump in this situation. So in evaluating a pump, we want to make sure that individual pump crosses the system curve. So this second selection might be a better choice for us. Now we could run 2 pumps in parallel. If we decide we're going to shut one off for either service or just for staging potential, you notice that a single pump doesn't run at 600 gallons a minute. If it's in operation, it has potential to run out here to 900 gallons a minute. Well, that's about 75% of what our plant requires at 1,200. So one pump will give us about 75% capacity. That's really great as far as parallel operation goes. Big advantage. If we're doing 3 pumps in parallel, you also have to evaluate that same criteria. Now, in this case, you always have to run at least 2 pumps because a single pump is going to have a hard time crossing the system curve, okay? It depends on your plant, your staging, your VFD. We haven't overlapped a VFD curve on this, but all those become evaluation points. So just be careful with parallel operation. That can come into play pretty fast as far as how you evaluate your pumps. If we bounce back to Systemwize and we look at one of these curves, you'll notice that the 4BD looks pretty good. Okay. If I look at the 4EB, that also looks okay. If I come down here to one of these curves that's a little further to the right of best efficiency point, we may have some red flags. We're close, but not great. We may get some real ugly selections with something like this. Okay, so software doesn't warn you. It's just something you have to be cognizant about when you're making a selection for parallel pumps. Okay, so I hope all that helps. Now, if we've created a schedule, bear with me for bouncing around here. If we've added multiple things, I'm going to cheat a little bit because I should have schedules to reference. I've saved these earlier. I can come in and edit or modify. I can come over and get I can get a spreadsheet for everything on my schedule. I can get full submittal package for everything on my schedule, as well as Revit and CAD files. Now, I have to caution you a little bit. I know Hans and I are super a little sensitive to this. A B&G submittal that you get online doesn't include the, typically doesn't include the flex coupler that's being used, or the seal type, or the motor, or shaft grounding. So we call this more of a proposal than a submittal. So if you're generating it online, it usually doesn't include all complete information, but it does give you a lot of good information. Now, let me bounce back to my PowerPoint real quick, and forgive me for bouncing around. Let me fire up my last poll because we're almost done here. Go ahead and launch that. Let's talk about generating documents. And again, back on a schedule, it's just a matter of selecting what you like. It does take a little while to download based on the size of those files, so I've kind of done that ahead of time. You'll end up with a zip file that contains CAD files and Revit files for the information that's or the equipment that was selected on your schedule. You'll get a Excel sheet of the schedule itself, as well as a submittal or proposal, depending on how you want to look at that. Here's what a typical submittal looks like, or proposal, forgive me. I'm going to transfer over to Bluebeam so you can kind of see what that package looks like. If I can get that to go. Hopefully that's working. So with this, you tend to look at a variable speed curve. Sunday, is that working okay? We got parallel curves showing up.
They are.
Okay. Constant speed, you got dimensional drawing. And then for a second pump, individual pump that's lead lag, no parallel curves. And then as we scroll down here, you're going to end up with suction diffusers for each pump, as well as air separators. Okay, in this case, I chose triple duty valves, and then we've got an air separator as part of this. So that's a typical package that you get online. We use the same thing in-house. We just add some more information and try to highlight things a little better, pointing out all the options that are included with the equipment. Now, I know this was kind of a crash course, so I apologize for that. I can tell you we're about done here as far as a quick overview. There's a lot that goes into pump selections. So yeah, don't be afraid to lean on your rep for some help. And we'll certainly add some heat transfer to the mix as far as a possible session number 6. Next week is boilers. Sunday, are there any questions or concerns we need to deal with? At this point, we're about wrapped up.
No, doesn't look like any questions. I did put my email in the group chat to everyone. So please email me if you did not receive our the email with the link for the closed loop systems course that went out a couple weeks ago. So you should have already received that, and it had a survey on there. So sperez@chchydro.com. Any questions before we close out?
Yeah, hey, this is Hans, you guys. I have one comment. You know, Paul did a great job of, you know, talking about those parallel curves. But keep in mind that just because the system curve doesn't cross, you know, the all system curves. Yeah, I don't know if you got, there you go. Yeah, this is showing that although you could certainly run 2 pumps at 60 hertz in parallel, it doesn't mean that you can't run 1 pump. It just means that you can't run 1 pump at 60 hertz. And yeah. So again, further evaluation would be warranted if everything else about that selection looked good. That was all I was going to comment on.
No, Hans, that's a great point, and it all comes down to pump staging, best efficiency points, where you want to bring pump number 1 on. Yeah, you might be able to run pump number 1 up to 40 hertz or so. If you picture variable speed curves tied on top of this, that's what Hans is talking about. So. And obviously, this system curve is going to fluctuate based on two-way valve operation out in the system. It's going to move left, and design day or worst case is going to be full output at 1,200 gallons a minute. So yeah, there's a lot of variables as it relates to parallel pumping, system curves, and how to stage pumps. So yeah, Hans, that's a great point. Just yeah, if we're I don't want to say that. not a red flag, but certainly warrants additional consideration here if we're looking to run a single pump in a large system. So yeah. Okay.
I think we're
As
good.
always, thanks everybody. We appreciate your time today, and we look forward to possibly seeing you next week about the same time. Wish you a good day.
All right. Thanks, everyone. Have a great day. See you next week.